Red Rocks Community College team designed an experiment to test the durability and viability of two types of DNA under the extreme conditions of launch and re-entry, to help with further understanding of the building blocks of life and contribute to knowledge about space travel. The purpose of this experiment was to further explore the resilience of plasmid and nuclear DNA. The types of DNA used were calf thymus and piglo. The plasmid DNA piglo is a bioengineered plasmid that has several reporter genes in the DNA strand. For the rocket launch, DNA was launched with approximately 0.5 milliliters of both nuclear and plasmid DNA, which were divided into a dry and wet subcategory. Dry DNA was launched without any liquid in the test tube. Wet calcium chloride solution was used to see if any shearing forces that were carried through the solution would affect DNA structure. We used 4 different testing methods. Needlepoint shearing, pushing DNA in and out of a very fine point needle, was conducted. We sheared the DNA in for 10, 50, and 100 times. Sonication is a way to produce hydrodynamic shearing. The process applies sound energy to DNA and vibrates it, creating shearing forces in water. The post-flight nuclear and plasmid DNA endured 4 trials of increments of 8 minutes. We used gel electrophoresis to properly examine our pre- and post-DNA samples. This laboratory method helped us to physically see how the DNA was affected in the process. DNA, RNA, and protein are organized by size. This occurs by placing an electric field through a gel containing pores with DNA. Plasmid DNA was also subjected to a piglo functionality test. E. coli was cultured and fed the piglo plasmid. If functional, the E. coli glows a fluorescent green color under ultraviolet light due to the activation of the reporter genes consumed. Our results revealed that needlepoint shearing tests showed that after 100 times of shearing plasmid DNA, it did not show a difference in structure when posed against the control. The nuclear DNA was examined and showed multiple breaks that were not existent in the control. With sonication testing, DNA showed no damage to the structure. There were no differences between the tested DNA and the control. Our piglo results showed that plasmid was intact and functional. Dry plasmid DNA samples were compared to control dry plasmid DNA samples to examine structure of the DNA strands. Wet plasmid DNA samples were examined along with the control wet plasmid DNA samples to examine changes in the structure of the DNA strands. When the tested samples and control samples were analyzed using gel electrophoresis, DNA strands were not observed. The wet and dry plasmid samples did not show any viable results that can be used to make any conclusions. In conclusion, viability of the plasmid DNA, both dry and wet, remained unchanged after launch, indicating resilience to extreme conditions of launch, space, and recovery. In contrast, the nuclear DNA showed more damage post-launch than the plasmid. DNA is very resilient and not as fragile as we initially hypothesized. Working in an intercollegiate team allowed us all to discover the challenges and reward associated with working on such a complex project. Patience and determination were key factors in the success of such an interdisciplinary and intercollegiate project.